So we're jumping right into example 1. It says divide the polynomial and use the result to factor the polynomial completely. So we are going to divide using long division. So we've done this before in Algebra 2, but as a little refresher, what you're dividing into it goes on the outside, and then the big one's going to go on the inside. So it'll be x minus 2 on the outside, 6x cubed minus 19x squared plus 16x minus 4 on the inside. Now we need to think, what times x gives us 6x cubed? Or, perfect, 6x squared. Or we could just divide that 6x cubed by x, and that would be 6x squared. So it's important when you're doing long division to stay organized. Notice how I wrote my 6x squared on top of the x squared term. Next step is whatever we write up top gets multiplied to both things on the outside. So we are multiplying. So 6x squared times x would be 6x cubed. 6x squared times negative 2 would be negative 12x squared. We always want our first terms to cancel. So in this step, we change the signs of this whole row. So we change the sign and change the sign. So it becomes a negative 6x cubed plus 12x squared. And then we add. So 6x cubed minus 6x cubed cancels. Then I have negative 19x squared plus 12x squared, which would be what? Negative 7x squared. And then we start from the top. So what times x would give me negative 7x squared? Negative 7x, perfect. Then once we write it up top, we multiply it by both things on the outside. So negative 7x times x would be negative 7x squared. And negative 7x times negative 2 would be positive 14x. What do I have to do next? Change a sign, change a sign. So the negative 7x squared and positive 7x squared cancel. I'm going to drop down this 16x and combine it with the negative 14x. So 16x minus 14x would be 2x. Then we do the same thing again. What times x gives me 2x? 2. So plus 2 would go next up top. What do I do next? Multiply. So once I write a number up top, it gets multiplied to both things out front. So that would be 2x minus 4. What's next? Change the sign, change the sign, because we want this to cancel. And then I have negative 4 plus 4, which is 0. So once you run out, we have an x squared, an x, a constant. After our constant, whatever we would have left down here would be our remainder. So here we have no remainder. When we have no remainder, what we divided into our polynomial, so this x minus 2, is a factor. So if we have no remainder, that means what we divide into it is a factor of our polynomial. So we divide to help us break down our polynomial, and then we can find our factors just by factoring. So now I have 6x squared minus 7x plus 2. How would I factor this now? So I just rewrote it from the top here. How would I factor this? Awesome. We start by multiplying the first times the last, so that would be 12. And what are two factors of 12 that add to negative 7? So negative 3 and negative 4. So I would have x minus 3, x minus 4. What do I have to do next? Divide by 6. So since I started by multiplying that 6, I have to make sure I divide by 6. What do I do next? Simplify the fraction. So this 3 over 6 becomes 1 over 2. And if the denominator still doesn't simplify, what do I do with it? Move it in front of the x. So this is now 2x minus 1. And then same thing with the 4 over 6. I can divide them both by 2 and make it 2 over 3. And what do I do with the denominator? Put it in front of the x. So this would be 3x minus 2. So 2x minus 1, 3x minus 2, and x minus 2 are all factors of my polynomial here. So we divide to help us break down the polynomial. And once we get to a quadratic with just an x squared, then we can just factor it like we're used to. But if it was an x cubed term, we may have to divide to break it down first. All right, on the next slide, the important thing to take away from here is if the remainder is 0, then d of x, which our divisor, divides evenly into f of x, which would be our dividend. So the first slide we did long division, but we also have synthetic division. So hopefully you've done both in Algebra 2. And if you have, you know that synthetic division is significantly easier than long division. So when we use synthetic division, we may be given like an x minus some number. So here it's x minus k. We change the sign of the number and that goes on the outside. We multiply numbers on the outside and add the numbers together on the inside. So these get added together. So we'll do an example and it'll be a little bit more clear in our example. So for example 4, it says use synthetic division to divide. Before we use synthetic division or long division, we have to make sure that all terms are represented. So if I start with an x to the 4th power, I need an x to the 3rd power, an x squared, an x, and a constant. So what am I missing here? X to the 3rd power. How can I include an x to the 3rd power? Perfect. In here, I'm going to put a 0x cubed. So we need all terms. So I'm going to include a 0x cubed since I'm missing one. And then for synthetic division, we have to make sure that that number on the outside, we flip the sign. So a negative 3 is going to go on the outside. Inside the box, I put the coefficients of all of my variables. So I start with 1, because the coefficient in front of x to the 4th power would be 1. Then I have 0, negative 10, negative 2, and 4. What's the first step I do in synthetic division? Awesome. Bring down the first number. So I drop down the 1. Then I multiply it with the outside. So negative 3 times 1 would be negative 3. What do I do on the inside? Add. So 0 plus negative 3 would be negative 3. On the outside we multiply. So negative 3 times negative 3 would be 9. Inside we add. So negative 10 plus 9 would be negative 1. Outside we multiply. Negative 3 times 1 would be positive 3. Outside we add. So this would be negative 2 plus 3 would be positive 1. Outside we multiply. So negative 3. Inside we add, we get 1. Now when we write our answer, it's always going to be 1 degree less than the polynomial that we started with. So if I started with x to the 4th power, my answer is going to start with x to the 3rd power. and then it's going to go down from there. So then my next term would be x squared, then just x, then I have my constant, and the last number is my remainder. So my answer here would be x cubed minus 3x squared minus x plus 1, remainder 1.
Do you have to put plus 1 over x plus 3?
I'm getting there. So we could write our remainder like this, or the other way we would write it would be as a fraction. So our remainder would be 1 over x plus 3, which I'm going to rewrite that so it's a little bit more clear. So my polynomial would be x cubed minus 3x squared minus x plus 1 plus 1 over x plus 3. And where did that x plus 3 come from? It was given. That was our divisor, what we divided into it. So
Would it matter if you put remainder 1 or 1 over x?
So I don't mind if you leave it like this. This is fine. WebAssign wants you to leave it like this. So WebAssign will make you put it as a fraction if you have a remainder. So we could use long division here if we wanted to. You'd get the same answer. But I think, in my opinion, synthetic division's a little bit easier.
So you could always choose which one you want to.
You can, unless the test or quiz says use long division. Then you have to use long division to solve, but you could always check your work with synthetic division. So you can do both. All right, next we have the remainder theorem. So the remainder theorem states if a polynomial f of x is divided by x minus k, then the remainder is f of that number. So whatever our remainder is would be the same value if I take that number, that k, and plug it into all of my x's. It'll make sense when we see it in an actual example. But whatever that k is, your x minus k, would be the same value. Our remainder is the same value if we take that k and plug it into all of our x's. So looking at example 5. I'm going to use synthetic division. And whatever our remainder is going to be that value if we would have plugged in -2 into all of our x's instead. But instead I can use synthetic division to find out what that value is. So inside my box I have 3, 8, 5, and -7. What's going to go outside the box? Be careful here, because here it gives you x equals. So when it's x equals, you put whatever it's equal to in it. Before we change the sign, because it was like x minus 2, but remember x minus 2, when we solve for x, we add 2, so it becomes x is equal to +2. So here it's giving us that x equals. We don't have to change the sign here. Do not change the sign here. If you change the sign, you'll get a different answer. So if it's x equals, you plug exactly what x is equal to outside. If it gave you something like this, where it's x minus or x plus, that's when you change the sign. So now we can use synthetic division. Drop down the 3, multiply the outside, add the inside. So 8 minus 6 would be 2. Multiply the outside, we get -4. Add the inside, we get +1. Multiply the outside, this would be -2. Add the inside, -9. So whatever our remainder is, that last number is f of -2. If I would have plugged in -2 into all my x's, I would evaluate it and get -9. But instead we could just use the remainder theorem to give us that value.
Oh, it's just the last one?
Just the last one is your answer. So to test it out, we're actually going to plug in -2 into all of our x's. So I have 3 times -2 cubed plus 8 times -2 squared plus 5 times -2 minus 7. So here I have 3 times -2 cubed. -2 cubed would be what? -8. And -8 times 3? -24. And then 8 times negative 2 squared. Negative 2 squared would be 4. 8 times 4 is 32. 5 times negative 2 would be negative 10, and minus 7. So then I would have 8 minus 10 minus 7. This would be negative 2 minus 7, which is negative 9. All right, so next we have the factor theorem. This theorem states that you can test whether a polynomial has x minus k as a factor by evaluating the polynomial at x is equal to k. If the result is 0, then x minus k is a factor. So same thing we did before. If we do synthetic division and we get 0 as our remainder, then whatever the number is outside would be a factor. So if we divide and our remainder is 0, then that number would be a factor. So here it says show that x minus 2 and x plus 3 are factors of our polynomial. Then find the remaining factors. So how could I test and see if these are factors? What can I do? Divide by both of them. So we're just going to do one at a time. So I'll start with the x minus 2. So inside my box I have 2, 7, negative 4, negative 27, and negative 18. Always make sure that all of your variables, the degrees, are represented. So I have 4, 3, 2, just x, and our constant. So everything's good. I don't have to plug in any zeros in here. What's going to go on the outside? Positive 2. Perfect. So we start by dropping down the 2. 2 times 2 would be 4. Add the inside, so 7 plus 4 would be 11. Multiply the outside, we get 22. Add the inside, this would be 18. 18 times 2 is 36. Negative 27 plus 36 would be 9. Awesome. And 2 times 9 is 18. Negative 18 plus 18, 0. So is x minus 2 a factor? Yes. So now we're going to plug in, yes. Yeah, we could. So just to practice long division, we're going to test x plus 3 using long division. It helps to see it. So x plus 3 is going to go on the outside of our box. What do you think I could plug in on the inside of my box now? I can plug in this one now. So since I started with 2x to the 4th power, this is now 2x cubed plus 11x squared plus 18x plus 9. So I'm going to take this and plug it inside the box because it's going to be a little bit easier to work with than using my 2x plus 4, or 2x to the 4th power. So we have 2x cubed plus 11x squared plus 18x plus 9 inside the box. So we're dividing using long division here. So what times x gives me 2x cubed? 2x squared. So that's going to go on top of my x squared term, just so I can make sure I'm organized. Once I write something up top, what do I do next? Multiply with the outside. So 2x squared times x would be 2x cubed, and 2x squared times 3 would be 6x squared. What do I do next? Change the sign, and combine. So 2x cubed minus 2x cubed cancels. 11x squared minus 6x squared would be 5x squared. Now again, start from the top. What times x gives me 5x squared? 5x. So then we multiply with everything on the outside. I get 5x squared. And then 5x times 3? 15x. What do I do next? change the sign, and combine. So the 5x squareds cancel. I'm going to drop down that 18x. So 18x minus 15x, 3x. Now what times x gives me 3x? 3. So plus 3 would come next. So when I multiply that to everything outside, I have 3x, and 3 times 3 would be 9. What do I do next? Change the sign, and combine. So the 3x's cancel. 9 minus 9 is 0. So remainder is 0. So is x plus 3 a factor? Yes. Now to find the remaining factors, I'm going to use the answer that I just got and break it down. So I have 2x squared plus 5x plus 3. Now I can find the factors here. So you want to use what it gives you, divide, so then you have a smaller polynomial that you can just factor. I can't factor this one. I guess you could, but it wouldn't be as fun as to factor this one. Okay. So we have 2x squared plus 5x plus 3. How do I factor this? Multiply the first times the last. So 2 times 3 would be 6. What are two factors of 6 that add to 5? 3 and 2. So in my parentheses, I have x plus 3 and x plus 2. What do I have to do next? Divide by 2. If you start by multiplying, you have to make sure you go back in and divide the first number. So we divide both of our numbers in our parentheses by that first term, 2. What happens if it doesn't divide? Bless you. Put it in front of the x. Chloe, what's your question? All right, let's finish this one, and then I'll answer whatever other questions you guys have. So here, 2 divided by 2 simplifies, so it would be x plus 1. So my two factors of this are 2x plus 3, x plus 1, and what else? X minus 2 and x plus 3. The two things that we started with that we had to divide to check and make sure that they were factors. So I could have done synthetic division twice, and when you do synthetic division, I would still use the answer that I got here, use synthetic division for that one, and then I would check it again. Then you use your answer you got here and then find the factors of that one. So your goal is to keep breaking it down to then find the factors of what you have left. So we could FOIL all 4 of these together and it would give us this polynomial that we started with. So that would be a way to check your work if you had time. So in summary, the remainder are obtained in synthetic division of a polynomial f of x by x minus k provides the following information. So the remainder gives us the value of x is equal to k. So whatever that number is, that k, that would be the value as if we had plugged it into x, but we could use synthetic division instead. It gives us a factor if our remainder is 0. And again, if our remainder is 0, it also gives us the x-intercept, because x-intercept and factor are essentially the same thing. It's where y is equal to 0, and it's where our graph crosses the x-axis. So if we had a remainder of 0 at that k, that would be a solution to our question, which we know solution, 0, x-intercepts all mean the same thing.